In this video, we are going to have a discussion on how to work question with a double slit experiment, and also we shall look at how to work out question that involve diffraction grating. And something that you need to know, this is a concept of superposition. And maybe in your exam you may be asked to define or state the principle of superposition, and you need to understand that the principle of superposition states that when two waves overlap, the resultant displacement is the sum of the individual displacement. That is why I've stated here that when two waves meet at a point, the resultant displacement is the sum of each of the displacements of each of the waves. So the waves are going to combine, and if the waves meet in phase, it means that after superposition you are going to have a resultant wave with a higher amplitude. Slit experiment is an experiment that was performed first by Thomas Young, and this experiment can be used to depict the wavelength of a wave. Now, for instance, we are having light emanating from this source, and then we are this interference to take place. This must be a coherent source, meaning the waves must be coherent for these bright and dark fringes to be formed. What do we mean by the term coherent waves? All waves are coherent. Remember, as waves move, they can have a constant phase difference, or they may have non-constant phase difference. Now, for coherent waves are those waves which have a constant phase difference. Now, to define that or to illustrate that, let me just draw two waves here. So if we have a wave that moves in this direction, that goes like that, this is the first wave, like that. And then I need also to add a second wave. Maybe this second wave is starting here. It goes like that, goes down, goes like that, goes down, goes like that, goes down. So these are two waves. We have wave A, and also we have a point here where the particle in wave B is maximum, and also a point where this wave is maximum. If we measure the distance for this wave here, and also we check some other point, we check the distance d. Also, if you check with this point here, the distance d, here the distance between the two waves, the two particles, is constant throughout. So it tells you that these waves have a constant phase difference. And if waves have a constant phase difference, it means the two waves are coherent. So which means that if you are going to use any waves here, the two waves must be coherent for them to interfere constructively or destructively, for you to have the bright and the dark fringes. When the waves meet, when they are in phase, they interfere constructively, and they result the formation of the bright fringe. If the waves meet out of phase, on the screen here, they interfere destructively, and they result to what we call a dark fringe. Because when we are having this source here, this wave, maybe let me just illustrate, this wave will move up to this point of the screen, because the source is going to act, this second slit is going to act as a source, and also this wave will travel from here, and the two waves are going to meet at this point. If they meet in phase, while they are in phase, it means they are going to interfere constructively, and a bright fringe is formed. So in that way, we are going to have a pattern of bright and dark fringes. So something else that we are going to discuss is also the path difference. That if waves meet where the path difference is equivalent to one wavelength, they are going to interfere in phase. Yeah, so meaning let us first focus on how to calculate the wavelength of light in a scenario like this if you are given a question in an exam. So something that you need to understand, the formula for double slit experiment is lambda is equal to ax over d, where a is the distance between the two slits, the distance between the centers of the two slits. The distance between this point and this point gives us a, and d is the distance between the slits and the screen, this distance that we are having at this point. And also we are having an x, and x is the distance between two adjacent fringes, bright fringes, the distance between two adjacent fringes. So in that case, let's try to substitute the values that we have so that we are able to get what answer do we get for the wavelength in this experiment. In this case, and something I need to remind you is that always check whether the units are in SI unit, because sometimes you'll be given units in millimeters, like for instance this one, you need to convert it to meters for you to work it out. So this is going to be 0.65 times x. Our x is 1.7 millimeters, so we shall say 1.7 millimeters. To meters we shall multiply by 10⁻³ divide by the distance between the slits and the screen, which is going to give us 1.9 meters. So if we can now put this in our calculator and check what exactly we're going to get in this case, let us put it in the calculator. (0.65) times 1.7 times 10⁻³ divided by 1.9. Working it out, I'm getting my answer as 5.8 times 10⁻⁴. 1, 2, 3, 4. -4 meters. This is the wavelength of this particular wave. So that is how basically this is the formula you use in order to work it out. So now I want us to look at how you can be able to work out the spectral lines in the diffraction grating. The formula you use for diffraction grating is usually n lambda is equals to d sine of theta, whereby n is the number of the order, lambda is the wavelength of the light that is passed through the diffraction grating, and then we have d is the line spacing in the diffraction grating, because a diffraction grating is a plate that has a number of slits. This one we were having just two slits here, but now diffraction grating has many slits, and then now multiple interference is going to take place so that we can be able to have all these orders that we have here. So in this case, we know the wavelength, it was provided. Number of the order here, n is going to be 3. That's what we shall use here. And the angle in this case is sine d, the angle is 68. So meaning that if we are finding d, we are going to say is 3, because the order is 3 for this particular angle that we are given, and then times lambda, which is 4.3, times 10⁻⁻⁷, divide by sine theta. I'm trying to make d the subject, so it's this d, d is equals to n lambda divided by sine theta. and in this case sine theta is sine 68. Then now you can put this information in your calculator so that you can be able to see what we can get, and that is 3 times 10, 3 times 4.3 times 10 raised to power negative 7 divided by the sine of 68. Working it out, we are going to get our answer as in the event in the exam they ask you how to define diffraction. They are going to say that diffraction is the spreading of the wave as it passes through the gap. And still we have an incident wave traveling in that direction. Then upon passing through the gap, the wave is going to spread out in that way. And the amount of diffraction depends on the size of the gap. If the size of the slit or the size of this gap that we have in here is approximately equal to the wavelength of this wave, then we are going to have maximum diffraction. So I want you to understand that for double slit experiment, this is the formula you are going to use, and for diffraction grating, this is the formula you need to use. So aspect like how does changing the wavelength affect the difference, the separation of the bright fringes, you're going to look at this formula. Increasing the wavelength, maybe shifting blue light to red light, because red light has a longer wavelength, it means now the separation of the fringes is going to do what? To increase, as I'm going to show you in the animation. Similar to this case, if you increase the wavelength, then it means that the angle is going to increase at this particular point. Those are some of the areas that you ought to understand as far as this subject and this topic is concerned. If you found value from Prof Learn YouTube channel, consider subscribing so that anytime I'm going to upload another tutorial on the same, you'll be notified. See you in the next video.